Good afternoon. Today we are going to see the problems that is on work energy principle. Now, first we will see the theory and then we will solve the problem. Now, I have seen that many of the students are interested with problems only, but you understand the theory very clearly. Study theory first and then switch over to the problems, because once your concepts were clear from theory, then it becomes easy for us to solve any problems related with that theory. If we will go to the problem, then you will understand that type of problem, not all types. So now this is my YouTube channel, Civil Engineers Technical Hub, and you have to go to playlist. And in this, you will see number of videos which are related with your engineering mechanics. Some of them are listed over here. So now today we are going to see this is conservation of energy, or we can say work power energy. So we are related with this. So now we can see the problems. Before that, I will let us go with this kinetics. Now, kinetics, this is mainly dealt with Newton's second law. Newton's second law. And we have this Newton's second law, that is summation F is equal to ma. Now, this is the only law actually which we have to use. Other are derived from this. So we have full kinetics only on Newton's second law, summation F is equal to ma. D'Alembert a little bit modify this, and he has taken m into a on left side, and he has written equation summation F plus minus ma is equal to 0, and he is going to say this is the equation of dynamic equilibrium, and minus ma according to him is D'Alembert's force. Means if you will apply mass into acceleration in the opposite direction of motion to the body, then at that instant your body is in equilibrium, and that is known as dynamic equilibrium. Now this summation F equal to ma, we are going to be simplified, and we have simplification turn out into two principles, which is known as work energy principle and impulse momentum principle. That means these are not direct principle. Actually, these are derived from Newton's second law. Which data is available, accordingly you have to decide which equation we have to use. Here we have FMA, which is available. Work energy, we have force into distance is work, and change in kinetic energy, that is right side. So if we have which data we have available, accordingly we will solve this. In impulse moment, we have Ft is equal to change in momentum mv minus mu. So we have to go likewise. Now you can see, I will just show you the derivation. F equal to ma, then we are using chain derivative, and it becomes dv by ds, ds by dt comes v dv ds. Rearrange the terms. We have f means we, sorry, no rearrange, we will put a in this equation. So mv dv by ds. Now we will rearrange it, and then we will get integration of this. Now f we have taken outside, means we are considering f is constant. And by integrating, we will get fs equal to mv square minus mu square by 2, and this is known as work energy principle. Work done equal to change in kinetic energy. If you will have this a, now here we have f equal to ma. And now if I will put a, that is dv by dt, then what will happen? Rearrange the terms. Sorry, substitute this a in this equation. What we will get? we will get F equal to m into dv by dt. And then you rearrange the terms and you will get F dt m dv. And then simplifying this, we will get this value that is equal to F dt equal to m dv. F is constant. And then from this we will get Ft equal to mv minus mu. And this is nothing but impulse equal to change in momentum. So this is impulse equal to change in momentum. So if relates with time, we have to use this. If it relate with distance, we have to use this. If it relate with acceleration, we have to use this. So you have to decide which equation will solve the problem easily. We have to go for that. Now in this, we are going to use work energy principle. Now we will go with this problem. Now see, the conveyor belt is designed to transport packages of various weights, each 10 kg. Means what is given? M is given. So we have M is equal to 10 kg. Mu k, that is given 0.15. So mu k is 0.15. Now initial velocity is given 5 meter per second. Suddenly stop means final velocity is 0. Determine the distance the package will slide on the belt before coming to rest. So we have to find out the distance. And then force given, velocity is given. So it is always better use work energy principle. And what is that principle? So we have that principle, that is F into S equal to mv square by 2 minus mu square by 2. Now try to understand, you have this package. So let us, I will draw the diagram. And this is given 10 kg. Is what is weight of this? So we have mg and m is given 10 kg. So we have m into 9.81. Now I am keeping m because m we have again on this side also, which I can cancel it. Now whatever weight you have same reaction, which is R, which is equal to 9.81 into m. Now we are interested to find the forces in the direction of motion. No force is given, so we have only frictional force. This is R, or I can say normal reaction. And then we have frictional force that is equal to mu R or mu N, and that is opposite direction of motion. We are assuming we have velocity 5 meter per second towards right. And then we will get this force that is equal to, given we have mu k 0.15. So we have this is equal to 0.15 into 9.81 into m. Now we will put it F into S. And in this F into S, we will get it as F we have minus, because force is towards left and distance traveled, it will go somewhere here and then its velocity becomes 0. Force, because due to frictional force, which is in opposite direction of motion, it comes to rest. And therefore we have minus F we have 0.15 into 9.81 into, let us, S distance covered. Sorry, here M we have 0.15, 9.81 into M also is there. And that is equal to M, we have final velocity is 0 minus M initial we have 5 square by 2. This M gets cancelled, minus sign get cancelled, and we have S equal to 5 square by 2 into 0.15 into 9.81. And from this we can calculate value of S. So that value just I will calculate 25 divided by 2 into 0.15 into 9.81. It comes 8.5 meters. So package will cover distance 8.5 meter before coming to rest. Then we have another problem. Calculate the velocity V of the crate, of the 50 kg crate as shown in figure, when it reaches the bottom of the chute at B. If it is given initial velocity, 4 meter per second down the chute at A. The coefficient of kinetic friction is 0.3. So given data you just see, what is distance covered? We have S equal to 10 meter. Then what is mass of the package? 50 kg. We have theta is given 15 degrees. Then initial velocity we have given, that is 4 meter per second. And then we have to find out the velocity at point B. So now let us, we will go, that is on next slide, and we will show all these things now. So let us, we have, so just I will rub this. So we have, so I will just draw it. So we have package in this fashion. Now this has 15 degrees. We have, this will be downward, that is M into G. Now we have reaction perpendicular to this. This will be normal reaction. Now this angle we have 15 degrees because this is 75. This angle is 75. So this comes 15 degree. So normal reaction becomes your cos 15. So it will be mg cos 15. Now in the direction of motion, we have mg sin 15. Now you can see kinetic friction is given 0.3. So your force due to kinetic friction will be towards left because is in the opposite direction of motion. And it will be mu k into n. And that is equal to 0.3 into mg cos 15. So we have force F that is equal to mg sin 15 minus 0.3 mg cos 15. Now we have block somewhere here. And distance cover we have 10 meters. So we have value of S that is 10 meters. Now we will solve the problem by using F into S equal to mv square by 2 minus mu square by 2. Now what is value of F? So we have M, we will take common. So we have G sin 15 minus 0.3 G cos 15. And that is equal to M. Final velocity we have to find minus initial velocity is given, that is 4 meter per second square. So 4 square upon 2. Now M we will cancel from all. And then we will get 9.81 sin 15. You can take common G also, minus 0.3 into 9.81 into cos 15. And then we have minus 0.30. So I have, this is minus 0.30. I will multiply it by 2 and I will write it v square minus 16. So this 2 will go on this side. And then we will get from this v square that is equal to 15.39. And from this I will get value of v that is equal to root of answer is 3.92. That comes something wrong. So 9.8150 cancel. So we have, sorry, this F into S, we forgot to take value of S. So this F we have taken and into 10 I will take on this side because formula is F into S. So we have to again multiply it by 10. And then this V square becomes 0.3 into 2 into 10, that is 6. So this V square becomes 10. And from this, I will get value of V, that is 0.3 into 2 into 10. This is 6 minus 16 and root of 10. This is 3.16 meter per second. So root of 10. And therefore, velocity at B is 3.16 meters per second. And then we will take one problem, that is a 2 kg pendulum 1.5 meter released from rest when it is at A. So we have initial velocity 0. Using work energy principle, when it passes 60 degree, means we have this as 60 degree. So we have F into S equal to mv square by 2 minus mu square by 2. Now this is free motion. So we have this as mgh equal to mv square by 2. And now initially 0. So this becomes 0. Now this gets cancelled. And therefore we will get V equal to root 2 GH. Now we are interested distance covered from initial and final. And that will be vertical. Why vertical? Because we have force that is in vertical direction. Weight is in vertical direction. Therefore, distance should be in vertical direction. And that how we will find, take horizontal distances between initial and final. And that will give you value of H. So we have this will be H. We have this as 1.5. So what will be value of H? So we have therefore H. So or I will write sine 60, that is equal to H upon 1.5. And from this we will get H equal to 1.5 sine 60. And that comes 1.3 meters. And from this we can find V equal to under root of 2 into 9.81 into 1.3. And we will get V equal to, so 2 into 1.3 into 9.81 root of this. So we have value 5.05 meter per second. This is work energy principle. So we have to find out, therefore, velocity when it passes 60 degree is 5.05 meter per second. So these are some examples which were asked in your paper on work energy principle. Now we will stop here only. Thank you.